Hello, students of Seneca, and welcome to this very exciting, for me anyway, maths predicted paper run through. My name is Richard. This is going to be my first ever live stream, so I'm excited. A little bit nervous, but as you are probably about your exams as well. So we're all in the same boat here. Today, what we're going to go through is we're going to basically have a look through some predicted paper questions. We're also going to look at some top tips for how to do as well as you can for your maths GCSE on Tuesday. Some little exam techniques to take forward with you, but also give you an opportunity to ask any questions you've got. I'm going to run through a few different topics that I think would be particularly useful for you guys to look through for your non-calculator paper. And then we're going to wrap up again by thinking about how you can de-stress yourself over the weekend and what you might want to do in terms of your revision for the weekend. You've got a few days to go until the big one, maths. All right, we know it's not everyone's favorite subject, but it's really, really important, and it's something that will go with you throughout your life. So we're going to get going in a second. I'm going to start by just looking through or talking about some different exam techniques that you should take forward with you into the exam. So firstly, while you're in the exam, really important that it sounds obvious, and I know you'll have heard this thousands of times from all your teachers and you're probably bored of hearing it, but read the question carefully. Now, examiners are really, really annoying, all right? And what they try to do is they try and trip you up by putting in little things to make you think that they're wanting you to do something else, when actually they want you to do something completely different. So read the question really carefully and think about how you approach every single question to make sure that you answer what the examiner actually is looking for. All right, so that's tip number one, read the question. Tip number two, answer every single question. Even if you don't have the foggiest idea what the question is about, have a go. There's no harm in having a go, all right? Just write some stuff down. At the very least, you might get a couple of like working marks. There are really funny things that examiners give marks for in the exam, even like sometimes adding two numbers together. If that's the first stage of a calculation, you might get a mark for that. So it's really, really important that you just have a go at every single question and try and get to an answer. Thirdly, 80 marks in the exam, 90 minutes. All right, so that means you've got about 1 minute for every mark. So the first few questions you'll see will be the ones that sort of ease you into the exam. You'll get about a few like 1 markers normally, and you'll have 1 minute for every mark. So if it's a 5-mark question, you've got roughly 5 minutes to complete it. Okay. If you start taking much longer than that, what I'd do is I'd move on to the next question and come back to it at the end. Okay. Next top tip is when you're finished, make sure you check through all of your working. It's so easy in maths, okay? As someone who, I back myself to add numbers up, all right? But sometimes it's so easy just to make a little bit of a mistake, all right? So you should also be aware of that as well, and be wary that you might lose the odd mark here and there just because you happen to add up two numbers wrong, which you know you can do, but because of the pressure of an exam, you might do it wrong. So it's really worth going back and spending time looking through all of the stuff that you've done and checking that you've done it correctly. Next, again, your teacher would have banged on about this, so I'm sorry to mention it, but show your working. Like always, always, always show your working. If you don't, the examiner can't give you quite a lot of marks. So when I said earlier, answer all the questions, that basically means always show your working and the way you try and get to an answer. You might pick up a mark here and there, okay? And lastly, well, actually, I'll talk about what to do over the weekend at the end. What I'll do now is I'll get stuck into some actual practice paper questions. If you've got any questions that want to come, that you want to come through me to cover in this live stream, then just pop it in the chat, and I'll try and go through as much as I can. What we've done is we've done a little bit of a poll on Instagram to look at what would be good to go through, and we've picked some topics. So I'm going to share my screen now. There might be a little bit of a lag as it moves over to the other screen, but you should still be able to see me. And so if I just do that now, you should start to see my screen now. So we're going to look at a predicted paper from Seneca, and we're going to start by just basically looking at some questions about standard form. And the reason this topic's been picked is because basically it's really, really easy marks, but also really easy thing to fall up on, to trip up on. So you might get a question that looks a bit like this. So simple as write this number in standard form. Now, very, very simple to do this. All you have to do is look at this number here and basically count how many jumps that decimal point is going to have to make until it's in standard form. Now remember, when a number's in standard form, it's just got one number, then a decimal point, then the rest of the number, okay? And then it's times 10 to the minus something, or to the positive something as well. So if we look here, we've got the decimal point here. It can do 1, 2, 3, 4 jumps to make it. So we've just got one number in front of the decimal point. So that means it's going to be 2.52 times 10 to the either minus 4 or plus 4. Now then you need to think about, is this number a really small number or a really big number? If it's a really small number, it's going to be to the minus 4. If it's a really big number, it's going to be to the positive 4. Well, this is obviously 0.0000 something. It's going to be to the minus 4. So the answer would be 2.52 times 10 to the minus 4. Next, there's a calculation with standard form, which again, it looks nasty, but it's really not as nasty as you think it might be. So it says also here, this is one of the things I'm talking about, reading the question properly. You should give your answer in standard form. That's something that will trip a lot of people up, and people will miss a mark for it. Okay, so with division of numbers in standard form, what you can do is just divide, in this case, the 2 by the 4. So 2 divided by 4, which will give you 0.5. And then you do 10 to the 9 divided by 10 to the minus 2. Okay, now when we're dividing by numbers with powers, what we do is we actually subtract the powers. So the answer is going to be 10 to the power of 9 subtract minus 2. So 9 subtract minus 2 will give you 11. Remember, if you have subtracting a minus number, it's going to be a plus. So it's going to be 10 to the 11. So what we do is then combine those two parts, and we put 0.5 times 10 to the 11. Now, what you need to notice here is that number is not yet in standard form. And this goes back to what I was saying in the previous question, that 0.5 times 10 to the 11 is not in standard form because basically you don't have one digit before the decimal point, okay? So it has to be a non-zero digit before that decimal point. So what you can do is you can say, okay, we're going to shift the decimal point 1 place to the right, and that will reduce the power of 10 by 1, okay? So, second question. This one's on prime factors. So, Lily wants to work out 124 as a product of its prime factors, but she's a bit stuck. She wants you to work the answer out for her, okay? So, you need to know that 124 as a product of prime factors, you can basically work through that, and you will know that from, hopefully from your classes, you can do one of those little tree diagrams. So you do like 124, okay, 2 goes into 124, and then that goes in 62 times. And then, okay, what goes into 62? Okay, 2 goes into 62. How many times does it go into? And you keep going to that until you get to all prime numbers, okay? And you'll eventually get to basically 2, 2, and 31. 2 is a prime number and 31 is a prime number. So 2 times 2 times 31 is the product of prime factors for this 124. Okay, and then what we can do is simplify it. Okay, so we got 2 times 2 is the same as 2 squared, and it times it by 31. And what could be better to finish an exam question than Winnie the Pooh, Donald Duck, and who's that? The mermaid, or Ariel, is it? Yeah, doing a little shimmy, right? Nothing better. Anyway, on to the next question. We're going to look at some of the dreaded algebra. Nasty stuff, that algebra. Anyway, you're not to worry because we're going to talk through it. It's going to be simple. Right. So this question is one that you'll see all the time, not necessarily with Homer Simpson, but you'll see similar sorts of things. So Homer goes to a shop to buy some lunch for his friends. He buys 3 sandwiches and 4 drinks, and it costs him £10.70. Bargain. I want to shop where he shops. He goes back to the same shop again the next day. The prices haven't changed, and he buys 4 sandwiches and 8 drinks, and that costs him £17.20. Either Homer's very hungry on the second day, or he's just got a lot of friends. I don't know which. But anyway, the question is, what's the cost of 1 sandwich and the cost of 1 drink? And use simultaneous equations to help you. Use S for a sandwich and D for a drink. Now, what you need to know is in the exam, they won't give you those last 2 lines. They won't tell you you need to do simultaneous equations, and they won't tell you what to call sandwiches and what to call drinks. But you know that if you've got this sort of question, you've got to basically form an equation and then solve it. So let's have a go at that. So first things first, we've got to solve those, form those simultaneous equations, all right? So firstly, we've got 3 sandwiches and 4 drinks, costs £10.70. So we can say 3S, S for sandwiches, plus 4D, D for drinks, equals 10.7, £10.70. And we can do the same for the second statement when Homer goes back again when he's hungry and he wants some more sandwiches. So we can say, okay, 4 sandwiches, 4S, plus 8D, 8 drinks, costs 17.20, 17.2. So we've got those 2 equations that you can see just here. Then we can basically multiply the first simultaneous equation so that both equations contain 8D. Now, the idea behind that is you basically want to have the same, what we call the coefficient, the number before the letter, in both of these equations. So the way we can do that, if you look at the top one, this one here, if we multiply that by the whole thing by 2, that's going to give us 8D, and there's 8D in this one. So that's a good start. We want to do that so we've got the same number of D in both of the equations. So if I multiply 3S by 2, that will give me 6S. If I multiply 10.7 by 2, that will give me 21.4. And the bottom equation, we haven't changed at all. So you just keep that the same. Okay. And then you just make 8D the subject of the first equation. So you do a bit of manipulation, moving stuff around. So if we want to make 8D the subject, that's going to mean 8D equals something. And what we can do is if we take this 8S away from this side, because we want to leave 8D on its own, remember with any equation, you have to do the same on both sides to make sure the balancing stays equal. So if I take 6S away from here, I'm going to have to take away 6S away from here. So do that on the left side, take away this 6S, and I also take away 6S from here. So I'm left with 8D is equal to 21.4, take away 6S. And the other equation hasn't changed. Now then what we do, it's a very long-winded question this, but it gets you lots and lots of marks, all right? So we substitute that, what 8D is, into the second equation. So we now know that 8D equals 21.4 minus 6x. So we can say, okay, if we change this for what we know 8D to be equal to, we can say that 4S is equal to 21.4 minus 6S. So that's all just from here, this part here. And that's still equal to 17.2. And then we rearrange. So we rearrange to bring the S's together. So 4S subtract 6S, collect those like terms, will give us negative 2x. And we can also get all the numbers onto one side of our equation. So we can do 17.2 subtract 21.4, again doing that from both sides, and that's going to give us negative 4.2. Then we divide by negative 2 on both sides to find the answer, and that will give us 2.1, or in pounds, £2.10. Final steps here. We're almost there. So once we've found what S is, we need to then find what D is. We found the cost of the sandwich. To link it back to what we're actually doing, we now need to find the cost of the drink. Now, if we've got 8D is equal to 21.4 minus 6 sandwiches, which I'm getting from up here, just bringing that equation down, then I know that I can say, okay, that's times 2.1, 21.4 minus 6 times 2.1, and that will give us 8.8 in total. So 8 drinks equals 8.8. So 1 drink equals 1.1, which is the same as £1.10. Okay, I'm not going to go into question 5 because I want to move on to a slightly different topic. But I'm just going to check, have we got any questions coming through? Lots and lots of questions. Too many to go through. Okay, if you've got any questions, keep them coming. Keep them coming in, and we'll see what's what. It's good to see lots of people on here learning or thinking about what they're going to do over the weekend for their revision. So next, we're going to have a look at a geometry question. So let's dig into that. So again, this is a classic question, and I've got some really classic tips for you, all right? So you'll get given like all this nonsense information that just sounds horrible, all right? JKLM is a rhombus. What? The line KJN is straight. The line MON is also straight. The point O lies on the line JL. Couple of angles for you to know as well. They'll probably give you the image of what this looks like in the exam. We've included it here. If they don't give it to you in the exam, you should try and sketch out what you know. Okay, so most likely they will, but sometimes they won't. So we've got this information up here. We've basically put in here. So just a little pointer, things like the angle JON. All that means is if we draw a line from J to O to N, it's like the angle that makes. Oh, hello, visitor.
Did someone say J to O to N?
I did indeed. Thank you, Jono.
You're doing great.
Jono's making an appearance.
I want to see some tea, some little bickies.
You brought a bourbon. What a legend.
You're doing amazing, sweetie.
Thank you.
Killing it. We're loving it. Keep it up. Enjoy
Thanks,
the
Jono.
bourbons and the tea.
I'm just gonna. Do you mind if I just eat bourbons from now on?
Delicious.
Is that all right?
Eat it.
Thanks, Jono.
See you later.
Right. Let's keep going. Keep going with the maths. Right. So JON is 65. Great. JKM, that again just means J to K to M. That's 77. Now remember, things you need to remember, you need to know about a rhombus and the properties of a rhombus. So this is the rhombus here. And you need to know that the sides are parallel, and they're also the two sides here, so M to L and K to J, they're parallel, and also J to L and K to M, they're parallel. And then you also need to know that all 4 sides of the rhombus are the same length. So we're going to have to try and basically work out a question based on this information. Show that LMO is 38 degrees. And you're like, oh my God, like what? How am I meant to show that LMO is 38 degrees? But don't worry, I'm going to talk you through how to do it. So the thing I would say, most important bit of like a tip I can give you for this is basically before you've even read the question, just try and fill in as much information on this diagram as possible. Okay, so say you know that this angle here is 65. You're also going to know that this angle here is 65 because the opposite angles are equal. Then you can also fill in like this angle here because you know that angles on a straight line add up to 180. So you know that angle there is going to be 115. And then you also know that that angle there is going to be 115. Then you can think, okay, what else can I know? Well, we know that 77 is here. What you need to know about a rhombus is that that angle will also be 77 here. So the JLM, that'll be 77. And also you should know that KML, this one here, will be equal to 180 minus 77. So we'll know that that's 103 in total. So you start to piece together all this information, and then so that's like how your problem solving process goes. You try and do as much as you can, and then eventually you'll get to the answer. So let's work through actually how to find this one that we're looking for, LMO. Okay. So first of all, you know that where are we? KMO equals is equal to angle JON. Okay, so you know that because they're corresponding angles here. So this is another way of doing it. So they're going to be corresponding angles, so they're both equal to 65. Then we've got that KML, so KML is equal to 180 minus 77, which we've already talked about, which is 103. Then we've got angle KML again is equal to KMO plus angle OML, okay, or LMO, same thing. So then you can basically use this information to work out what the missing angle is, what the missing LMO angle is. So angle LMO is equal to angle KML minus angle KMO. So we can just basically fill in what the calculation we need to do is here. So angle KML, let me just look up here, was 103, and angle KMO, where was that, is 65. And if we do the subtraction there, we're going to be left with 38 degrees. So what I'd say is like fill in all the information you know. That will suddenly make it a lot easier and hopefully jog your memory on how to do this. Right, another question. Last question we're going to have time for. So we're going to look at, let's have a look at some line graphs quickly. There you go. So you've got two lines. Y equals x, 5x plus 14, and 20x equals 4 minus 4y. Are these lines parallel? So you need to know a few things for this. You need to first of all know how to rearrange an equation to make it so that y equals something. So we're going to have to change this line 2 so y equals something. And we also need to know that when lines are parallel, they have the same gradient. And you'll remember that from your maths lessons, the formula y equals mx plus c. So that's y equals a number times x plus another number. And that first number that you times x by is the gradient. So if the gradients are the same, then we know that they are parallel. But let's have a look. Let's work through it and see what happens. So write the equation of line 2. So 20 is equal to 4 minus 4y. And then you need to make y the subject of this equation. So what we can do is we can add 4y to both sides, and we can take away 20x from both sides. So minus 20x plus 4, that will leave us with 4y equals minus 20x plus 4. To recap how I did that, what I've done is I've subtracted 4y from here and subtracted 4y from here. Sorry, added 4y, apologies. Added 4y here and added 4y here to leave us with 4y plus 20x equals 4. And then I've subtracted 20x from this side, and then I've subtracted 20x from this side. So we have negative 20x plus 4, and that's the same as 4y. Then what we do is we want to get y on its own. So it's 4 times y equals this at the moment. We just divide by 4 to get just y on its own. So we divide by 4 this side. Remember what I was talking about balances earlier. If we do divide by 4 on this side, we need to divide by 4 on this side. So we divide all of this by 4. So minus 20x divided by 4 is minus 5, minus 5x, and 4 divided by 4 gives us 1. So then you compare the gradients. So line 1 up here has the gradient as the equation y equals 5x plus 14. So the gradient there is 5. And here we've got y equals minus 5x plus 1. So here the gradient is minus 5. So those gradients are actually not the same. Okay, one gradient is 5, one gradient is minus 5. They're the same steepness, but they're just opposite directions. So if that's 5, that would be minus 5. Okay, so the answer, are these lines parallel? No, because they don't have the same gradient. Have we got time to go through one more, do you think? What do we think? Let me know if you think we've got time to go through one more. Seeing some good comments coming through. I don't think we're going to get time to go through binomial distribution today, I'm afraid. But we will go through one more question because I think it looks like people want to have a go at this. If you want to have a go at this last one as I do it, I recommend you do that. So this question is, we've got the graph y equals f of x. What the f of x are we talking about? Well, this graph has 2 turning points, all right? What a turning point is just basically where the graph turns. So here we've got the graph coming down, 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 and then it turns here. So that's one turning point. And then we're going up again, and it turns again here. And that's another turning point. So approximately, what are the coordinates of the turning points? Well, what we can use is, remember, along the corridor up the stairs when you're doing coordinates. So how to get to this point here, one turning point, I go along 0 and I go up the stairs minus 1. So it's going to be 0 minus 1. And then this point, I go along the stairs 1 and I go up, sorry, along the corridor 1, and then I go up 0. So it'll be those two. Next, estimate what the roots of f of x equals 0 should be. So I go back to the graph for this. F of x equals 0 is basically when y equals 0. Okay, so we're looking at this line here. So when y equals 0, that's all the points that y equals 0. I'm just running my mouse along it now. So that you're looking for the points that the line either crosses or touches this line that I'm drawing out. So first of all, we've got the x value here is minus 0.5. So x is minus 0.5. And the second one is just here where it just touches this line, y equals 0, and that is at the point x equals 1. Next, estimate the value of f of 0.5 using the graph. Now, what f of 0.5 means is you basically find the x value where it's 0.5. So when x is equal to 0.5, you basically go across to 0.5 and you look up and down that value of 0.5 to see where the graph that we've drawn crosses. And we can see it crosses just here. And that's at negative 0.5 in case you can't see. So that means the value of minus 0.5, the value of f of 0.5 is minus 0.5. And that guy is chuffed with my performance. I'm chuffed with my performance. And you're going to be chuffed with your performance after your exam on Tuesday. So that is the last topic we're going to look at. Last thing I'm going to do is I'm going to run through those tips for you again. First of all, remember, read the question carefully. Don't let the examiners trip you up. Don't be that guy. Secondly, answer all of the questions. Even if you have no idea, just answer them. Put something down. You might pick up a mark here and there. Lastly, thirdly, 80 marks, 90 minutes. 1 mark per minute. 5 mark question, 5 minutes. 3 mark question, 3 minutes. 1 mark question, 1 minute. Stick to that and you'll be good. At the end of the exam, check through your calculations. It's really easy to make a little calculation error. Also, show you're working. It's like the easiest thing you can do to get extra marks is show you're working, so do that. And what you should do over the weekend, you've got a few days to go into the exam. is practice, practice, practice. It's the key to maths, is you'll see the similar questions come up over and over again. And the more you practice, the more familiar you'll get with your methods and the better you'll be at them. So do that and you'll be absolutely fine. So that's all we've got time for in today's episode. I've really enjoyed doing the live stream. I hope to do them again soon with you guys. And what so I've answered a few of the questions. Alfie's asking how he should revise. You should just do loads and loads of practice questions, as much as you can, go over them all again. Thanks for the heart back to you, Alfie. Just keep going, and you won't be finished in too long. I know it feels like you're still right at the beginning, you've got so far to go, but actually you will be done before you know it. So best of luck. We'll be doing live streams every single weekday at 4:45 and 5:30. So join us for them. We'll also always be releasing the night before podcasts on our podcast channels, so check those out and get going on Seneca and to do all of your subjects, because that is the place to be. Right. Thank you. Over and out. I'm going to have a bourbon.